For decades, producers have fought the problem of lost pump efficiency due to downhole gas interference. Downhole pumps can lose between 20 to 100% published efficiency due to free gas problems. To correct this problem, producers have tried a variety of remedies. The most common were made from materials found in pump yards, even common today, such names as Mother Hubbard and Poor Boys, which are simply perforated and orange peel joints of pipe or subs. This method and others are limited to the fluid efficiency on your barrel per day due to limited space. Although these tools have proven limited and somewhat helpful in pump operations, they still do not solve the root problem, gas interference. When the Stanley Filter Company created the technology of gas separation, we knew immediately we needed to conduct tests to substantiate this technology with the Stanley gas separator and the traditional separators mentioned in the intro. Laboratory testing were conducted in-house and at STEM labs located in Duncan, Oklahoma. These labs and field tests combined were to conduct the level of flow, pressure drops, and gas separation, with the STEM lab simulating downhole testing beds using a 14-inch GS 3.5 separator. Water and gas were induced into the test well 3 feet below the separator. Liquid rates ranged from 20 to 1,000 barrels per day, and gas rates from 20 to 50 MCFD, which was due to the short length of the test sample. Results were, at 650 barrels a day of fluid, the separator was 98% efficient and successfully sufficient to go to market. As you will see here in a moment, by watching the model, we will simulate conditions by injecting nitrogen into the two units, which will allow you to see the results of the two comparisons in less than a minute. Gauges located on the display will show you the rate of pressure and pressure drop while they are working side by side. In the chamber you're looking at here, this is an 18-inch section of the Stanley gas separator. In a normal manufactured application, the separator starts at 6-foot lengths and goes up to in lengths and diameters. As you will notice, the separator is a stationary working tool with no moving parts. This allows the stationary vanes to impart a tornado-like or free vortex rotational velocity. The velocity generates centrifugal force that separates the fluid to the center of the mandrel and the gas particles trapped in the outside of the chamber, and allowing the gas to continue to travel up and to the back side of the annulus. This system generates a positive pressure flow for both the fluid and the gas particles. Results: fluid to continue to travel at an accelerated rate, the other decreasing the chances of the system's pressure to drop as the gas travels freely upward. Adjacent to the Stanley separator is your standard Poor Boy perforated sub with a dip tube inside. This has been proven and will be shown to be still an irrotational flow in a problem domain for pressure in the well. We are showing here that both models are equipped with the same size pumps and the same plumbing for equal comparison. Our engineers tried several different models of stationary vanes, and after each design change they reran the simulation in order to measure the impact, performance, and flow. The goal at this stage is simply to move as many gas particles as possible to the outside chamber while minimizing pressure drop. Here you see the nitrogen being injected into the chambers at equal levels. You're looking at the gauges here now, the Stanley on the left, the Poor Boy on the right. You're seeing it begin to gas lock. We're looking at the Poor Boy tank now. You'll see the what was causing the gauge to show gas lock. It'll just completely quit pumping here in just a second. This is just the gas circulating into the tank after the gas lock. Now we're looking at the Stanley tank. As you can see, solid column of fluid and no gas. Okay, now we're down looking at the Stanley gas separator, right coming down from the tubing where you saw a solid column. The Stanley gas separator would just continue to run all day long. If you had the patience to stand here and look at this thing, it would never change from, on the gauge or gas lock on you. In the comparison, we're looking at both the Stanley separator and the poor boy here at the same time. Just a few words about the separator. It goes to work immediately when you install it in the well. There's no waiting time or checking it out. A person can go up to the wellhead, open that 1-inch bleeder valve, and you'll get zero percolation coming out of it, telling you that you are separating gas out of your well. It's coming up the annulus where it's supposed to. So that's one of the things that I always recommend someone doing is once the well goes back to pumping, after you've installed it, go up and crack that 1-inch bleeder valve up on the wellhead and be surprised at what's happening with your well. You'll be amazed at what you see. Thank you for watching our demo on the Stanley gas separator. For further questions, go to our website www.stanleyfilter.com, and you can also contact your nearest Stanley representative for information on the Stanley gas separator and our other sand control filters. Thank you very much for your attention today.